Please wait. There we go. Hang on, sorry. The physics students made me extra stupid today. I don't have this plugged in. This is the main problem. Did anybody study physics in high school? Yeah. That bad, huh?
Yeah.
I think studying physics is not
Oh, there we go. Okay. So, hey, we'll start now. Victor! We'll start. Permutation and combination. Oh, there we go. So, Marcelo, did you write this down? Come on. So, you got this? No. I will talk about those in a moment, don't worry. Now, these words have a similar meaning, but there is a difference between them. So, for example, if I have like, we'll put the line down the middle. So something like your PIN code for the bank. Enter your PIN code. How many numbers? 4 numbers. So 1984. Don't worry, this isn't mine. Yeah, sure. Yeah. This PIN code 1984. That's different to this PIN code 4891, isn't it? Yeah. So the order here is important. Or you could have, 1, 2, 3, 4, whatever, etc. These are all called permutations. So how is this different to a combination? Well, I'll give you an example of a combination. So if you go to the shop and if you need, if you need to get milk, eggs, and tea, that's the same as going to the shop and getting tea, milk, and eggs. They aren't different. They're the same shopping list. And so this is called a combination, when the order is not important. So what we're going to have a look at in this lesson is actually just permutations today, where the order we do care about. Can you give me some more examples of a permutation? So what else is a permutation?
Cards.
Yeah?
Identify the card. I forgot the name.
Identify the card.
Like that, they do the
Barcode?
No.
Oh, the license plate. Yeah. So it's like if your car was something like 08D1234, something like this. Yeah. This is an example of a permutation because that's a different car to 2134. It's different. What else?
DB number.
Your DB number? Yeah. Your phone number? These are all permutations. Okay. Have you got those words? Permutation and combination. Yeah. So, and this is what we'll look at in the next lesson, but this lesson we're just looking at permutation. So we'll have a look at some examples. So the first example is if you have, let's say, 3 books on a bookshelf, ABC. So you can rearrange them. And the way you can think about rearranging them is like this. So when you put them on the shelf again, in the first spot, how many books could you place in the first spot? You can put A, B, or C there. What's your choice for the second spot? There's only 2 left that you can put on the second spot, the one you didn't use first time. And for the last spot, 1. Now the question is, how many possibilities are there in total? It's 6. How did you get 6? Yeah, you multiply across. So you had a choice of 3 for the first spot, 2 for the second, and 1 for the last. This actually has a name. It's called the principle of counting. Counting. You know, count 1, 2, 3. Yeah. And the idea is that you multiply to get the total possibilities. So here the answer will be 6. What about if I had 4 books? 4 multiply 3 multiply 2 multiply 1. Now does that sound familiar? 3 multiply 2 multiply 1. What does that equal to? That's the same as 3. Do you remember the word? Do you remember this? Yes, it's called factorial. And if you had 4 books, it would be 4 factorial. What about if you had 1 book? 1 factorial. Which is 1. And 0 books? 1. Because 0 factorial is 1. If I have no books on the bookshelf, how many ways can I arrange this bookshelf? 1 way. The empty way. Some people are happy with this, and some people are very unhappy with this. The biology teacher, he's very unhappy with this. He doesn't like this. Yes. I don't know. He's got issues. I don't know. So, some people get this idea, some people don't. If you have no books, that's 1 way to arrange it. The empty way. Yeah. Okay. Try this one for me. So, imagine I had cats. I want to rearrange this word. How many ways can I rearrange this? How many ways? 24, yeah. 4 factorial. Okay, so this is how we can use factorial. Okay. Let's say something a little bit different. Let's say you have a group of 5 people now. 1, 2, 3, 4, 5. And you want to pick out of the group 2 people. Maybe first place and maybe second place. A prize. How many permutations, how many possibilities are there? It's not 5 factorial. Not this, no. How much? 20. Because how many people could 5 and here 4? So then total there's 20. No, that's a different one. I'll show you that one next, okay? That's a different one. Okay, can I go down? Yeah. Okay. Try this one. I want to make a PIN code. So the rules are for your PIN code, there must be 4 digits. And then not start with 0. And also no neighbor or no run of digits. Does anyone know what I mean by run of digits? So a run of digit is when you have the same digit twice, like 1, 1, 2, 2, 3, 3, 4, 4, 4. No run of digits means the neighbours can't be the same. Yeah, so 4,698 is the answer, or? I don't know, I haven't thought about it yet. So how many possibilities are there? Okay. So for the first box, how many choices do you have? 9. We can't use 0, so there's only 9. For the second box, how many choices? 9. You can use everything except the last digit, but you can still use 0 though. But you just can't use the last digit. So there's still 9 here. And this one here is
8. 9.
this one here is 9 because you can't use only the last digit, but you could reuse the first digit.
You can repeat it. No random tickets. You said nothing repeated.
None of the digits, correct. No, but you could have 2, 1, 2. That's okay. You couldn't have 2, 2, 1.
Okay, so
yeah, the neighbours.
Yeah.
You can repeat, but you can't repeat. The neighbour can't repeat. Yeah, that's what it means when you say run here. So there's 9 for this choice. Yeah, and then for the last one, 9 as well. Yeah. Is that what it is? Yeah. It's 9 power 4. Yeah. Okay, now let's try this again, but this time I add in an extra rule. Now this time, instead of saying no run of digits, this one is no repeats. Any repeats now. Okay, so this time, how many for the first one?
9.
Still 9. 9. 8. Wait, hang on. 9. It can be anything except the first one. Yeah. Now this one here, it has to be 8 because it can be anything except the first one and except the second one. And these will be always different. Yeah. And then the last one here, 7. Yeah. So what is this one then? 4, 5, 3, 6. Okay. So we get the idea of what's happening here with these. Let's have a look at something a little bit more difficult. So let's take this word. I want you to tell me how many ways you can rearrange this. And it's not really 24 because the letter, the O is repeated, yeah. So just how many ways can you rearrange this? I don't think it's 6. Not 24. Yeah, why? You had a look of a guess. Why? Just a guess. Anyone know why it's 12? So I'll explain with this example, okay? So, no, it's 12. It's 12 it is. Now the reason is, if you look at the word book, let's take something where it is 24, like A, B, C, D. 4 factorial is 24, isn't it? So this is the first one, and then we could have A, B, D, C. Oh, hang on now, this is so easy to get screwed up. A, B, D, C. A, C, B, D. A, C, D, B. A, D, B, C. A, D, C, B. And then this repeats again, except this time now we start with B. I won't write them all out, you get the idea. But this one here, imagine that this was like A, B, C, D. every time B and C swaps places, it's not really any different. Like if you look here, let me see, where's B and C? This one here and this one here, they're actually the same in the case on the left because there's no difference between the second and the third. So if you swap them, you actually have the same possibility. So what you do in this situation is 4 factorial, but you need to divide by 2 factorial because that's how many ways you can repeat the OO. It can be rearranged 2 ways. It's a bit like a formula. So like for example, if you have AA, BBB, CCCC, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's not 9 factorial. Because when the A rearranges, it's the same. So there's a 2 factorial you need to divide by. And here there's a 3 factorial and here there's a 4 factorial. So there's much less because of the repeated permutations by repeating the A's, the B's and the C's within themselves. Factorial's on the calculator. It is, yeah. Yep. Okay. Have we got the idea here for this one? Yeah. Let's have a look. Okay. Let's scroll down. Can I scroll down? Yeah. So just a little bit of notation. We know this one's called factorial, which is n minus 1, n minus 2, until you get to 1. Does anyone know this one? Yeah, what is it? That's okay. So you mean you did know it? Yeah. Yes. Anyone know it now, in the present? So
I think n factorial over something?
No, not this one. You're thinking of the C. Yeah, not this one. This one here is n minus 1, n minus 2, but you only have m of these. So for example, 10p3 would be 10, 9, 8. This one here. So for example, if I had red, orange, yellow, green, blue, indigo, violet, I have 7 colours, and I want to make a flag for my new country. Let's call it the land of Stephen. United States. So how many possibilities do I have for my flag? Well, for the first colour in the first square, there's 7 possibilities. How many colours can I make for the second one? I have a choice of 6. Because we don't really repeat the colours in the flag, there are 3 different colours for flags like this. And for the last one? I suppose it could be 6, yeah. Because this one could be the same as the first one. Yeah. But if I wanted 3 different colours, then it would be 5. Which would be 7p3. Yeah. I'm trying to think of a country now that has its colour the same at the start and at the end.
Italy?
No, I think it's the different. All 3 colours are different. No, Japan is not a tricolour. Japan is 2 colours like this, isn't it? Yes. I'm thinking tricolours, please. Do you know one?
Canada?
No. Canada's like a leaf or something, isn't it? Oh, well, I guess it's red, white, red with a leaf in the middle. Okay, that's the closest then. Canada. Canada is red, white, red, isn't it? Yeah. Can't think of any. Okay, now, let's see, we'll do one more. Green, white, green, is it? Yes, yeah. Good. You know your flags, very good. Okay, let's do, how many choices do you have for your courses? So, there's probably, what? 1,000 courses you can choose from. You think it's that many? Okay, we'll say 1,000. How many choices do you make on your application form? Is it as many as 5? Oh, well, if it's UCAS. Is UCAS 5? Yeah. So UCAS, there's 5 choices, but the order is important or is not important? It is important. You have a first, a second, a third choice, don't you? No.
I think when you get the 5, you choose only 2. One is your first one, and one is the insurance company.
For UCAS? Oh, okay. So there's really only 2 choices then, the first choice and the second choice. So how many courses can you choose from for your first choice? 1,000? Do you think it's that many? So the answer for the number of application choices is 1,000 P2. You have 1,000 first choices and 999 second choices because you don't choose first one again, right?
That was right, like 1,000 factorial over.
No, this is not.
Minus.
This is 1,000 times 999. It's not actually the same as 1,000 over 2 factorial.
No, that's over 2.
Oh.
1,000 minus 2.
Let's do it this way. Yeah. This is 100 P2. What else could we have? Let's do something else interesting. Alright. Starbucks. How many choices do you have? So the first thing you say is what type of coffee you want. So we've got Americano. What else? Americano, espresso, cappuccino, latte, frappuccino. Well, let's stick with the hot drinks first to make it easier. Hot drinks. Mocha, hot chocolate. That's 6, isn't it? Anything else? Macchiato, thingamajig. 7. Anything else? That's it. Right, so there's 7 hot drinks. Then what's the next choice you need to make? The size. There's actually 4 sizes. What are the 4 sizes? No.
What size is it?
Tall, grande, venti. There's actually a 4th size called short, which is smaller than a tall, which nobody knows about. Smaller than tall. Yeah. So it actually goes short, tall, grande, venti. So there's 4. What's your next choice?
Sugar.
But they don't ask you that. Well, not sugar. What is it? Cream? Yeah, if you want whipped cream. So how many choices here? 2. Yes or no? What else? Chocolate on the top. Okay, good. What else? So this is the type. This is the size. What was this one we said? Cream, whipped cream, and this one chocolate. What else now? Could they ask you? Come on, you all go to Starbucks. Imagine what else you can get. Huh? Of course there is, yeah. You could ask for a syrup, couldn't you? Vanilla syrup, hazelnut syrup. You know syrup, don't you? Yeah. Well, then you don't ask for a syrup. So you have choices. You can say no syrup, vanilla syrup, hazelnut syrup, caramel. Anything else? There's 4. Okay. Also, what else? Anything else? soy milk.
Ah,
You could have normal milk, soy milk, or low fat milk or something. So there's three choices here.
like takeaway or
Takeaway or not, yes,
yes.
but it's the same drink. So, well,
Like common different.
yeah, maybe it tastes different. Okay, takeaway or not. I think this is everything, isn't it?
Some things in the top.
Sprinkles on the top. I think that's this one really. Anything else?
Cash or card.
I think a cash coffee and a card coffee taste the same. So yeah. Okay, I think that's it. So this is what number? Tell me how many possible drinks there are in Starbucks then. And this is only hot drinks they can make for you. It's a big number. Say again? 2,688 hot drink possibilities. Yeah. I don't think there's any. I think the basic idea we have it. So this lesson is only permutations like this. Tomorrow will be combinations. Okay. Yeah. Right, try these for a few minutes. He's hung over, is he? Was he out last night? No, you can tell me. It's okay. You what? Okay, you want some of these. Can you take one for Albert? Yeah. Do you want to take one for John Way? What's wrong? Good. Did I? Sorry, the physics student just crossed me. Of course, there's absolutely no A there because that's a permutation or something. Yeah, there's no A here. That's disgraceful. Right.
How's your order in there, sir?
Hang on. Let me check something here. Oh. Yeah, somebody can tell me why 1B. Why is 1B a permutation? Starter, main, and dessert. If they bring the dessert at the end, that does matter to you. So the order is important. If I ask for soup, beef, and ice cream, and they give me ice cream, soup, and then beef, no. You wouldn't mind? Okay, well, yeah. Well, the point is the order is important. You do care about what order you get the food. So it's a permutation. Really? Yeah. Oh, well, Irish restaurant then. Really? Chinese restaurant just doesn't matter, whatever, bring it down? Okay.